In this video, I'm going to look at the proof of the derivative that d by dx of x raised to the power n is equal to nx to the n minus 1. If we consider our definition of a derivative, which is the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. If we replace f of x in this expression with f of x equals x to the power n, so we just replace that in our limit expression, we get this equal to the limit as delta x approaches 0 of x plus delta x to the power n minus x to the power n over delta x, just substituting x to the power n for f of x in our original expression. Now if we use the binomial theorem to expand this expression x plus delta x to the power n, and you can find out more about the binomial theorem by looking at the video on the definition of the binomial theorem, then this expansion becomes x to the power n plus n choose 1 times x to the n minus 1 by delta x plus n choose 2 by x to the n minus 2 by delta x squared, and so on and so on, until we come to the last term of that expansion, of course, which is just delta x to the power n. The rest of the numerator we're left with take away x to the n, and in the denominator we still have delta x. If we look at this expression in the numerator, we can see that there's an x to the power n and a take away x to the power n, so that term will just cancel out. Also, every term in the numerator has a delta x in it, so delta x will cancel out as well with each term in the numerator. So we get left with just 1 in the denominator. Now, if we think about this expression, what happens as delta x approaches 0, all the terms that have a delta x in them will become increasingly smaller. So the limit as delta x approaches 0 is just this first term that doesn't have a delta x expression in it anymore. So our definition becomes n choose 1 times x to the n minus 1. And of course n choose 1 is just n. There's only n ways you can choose one object from n objects. And that leaves us with our definition of d by dx of x to the power n, which is n times x to the n minus 1. And that's how we get an expression for the derivative of a function, where n is an integer, and as it so happens, of course, this expression holds true for non-integer values of n as well. Now I'm going to look at a couple of examples of calculating the derivative. Let's have a look at just a simple one, d by dx of x squared. By the definition we've just come up with, then we take the exponent, put it at the front, so it becomes 2, and the exponent's reduced by 1, so it becomes 2x to the power 1, or just 2x. In the second example, we'll look at the derivative of x to the 5th. Again, following the rule we've just derived, we put the 5 out the front of the x, reduce the exponent by 1, and our result is 5x to the 4th. So derivative of x to the 5th, 5x to the power 4.
For more free tutorials and the PDF for this tutorial, visit www.handwrittentutorials.com.